let's talk about the property of integral, okay? So first one is really obvious, right? Integral a to b c dx, which means your function is constant function, right? So like, I can show you like with the graph, okay? Here we go. So your function is continuous function. I mean, constant function, right? Which is horizontal line with c, right? And then they would like talk about the area between a and b. A and b, for example. Okay? Then this area. Oh, come on, don't kid me. That is the area of rectangle, right? So area of rectangle is base. B minus A is the base and height, okay? So that is the area of rectangle, which is exactly the definite integral for the constant function, okay? And number 2, 3, well, we say it is a linear property, okay? We already discussed about this one before. So whenever you have like, constant coefficient, and it can be written in front of your integral, and whenever you have functions are added or subtracted, you can separate two separate integrals with the same interval, okay? And number 4 is obvious, right? As we talked about it, you do not have base, which means you do not have any area, okay? So which means like your lower limit is equal to upper limit, and the integral value equals 0, okay? And number 5, I already gave you the example about this, okay? Basically, like your integral must be left to right, but if you want to change the direction, it is exactly opposite value of the integral, okay? We can prove this one by the definition, okay? But number 6, number 6 is really interesting, okay? We would like to talk about integral a to b, but on your right-hand side, it is same function, but like, it is like, separated to different interval, okay? Let me give you the idea, okay? Here we go. So if your function is here, like that, from a to b, okay? So this whole area is what? Integral a to b f of x dx, okay? But if you just want to do, because like it's too tired, just like I calculate the area from a to some point first, let's say it's c. Then we know that the area of this one, right? It is integral a to c f of x dx. Then you will do leftover later. Integral c to b f of x dx, okay? Which means when you add up these two, it can be area between a to b f of x dx. This is the meaning of number 6, okay? But another interesting is like, for this figure, I said your C point is in between A and B, right? But it actually doesn't matter. Your C could be out there or out there, okay? And because of the like property number 5, and it is same property is working like for that situation as well, okay? So now let's talk about number 7. Number 7 is like an upper bound and lower bound, okay? Let me tell you in the word, like in the meaning of this, okay? First of all, your function f has upper bound capital M and lower bound small m, right? As long as your function itself has the upper and lower bound, then your integral of your function will have upper bound and lower bound with these forms, okay? So it really makes sense to you, okay? So let me give you the, like, the graphical explanation about this, okay? So first of all, you have function f here between a to b, okay? So your curve is like that. And then we assume there is upper bound, let's say it's capital M, and there is lower bound, small m. Is it okay? So, okay, so first of all, the area can be noted by the definite integral, right? Integral a to b f of x dx, right? And then think about with the same interval a to b, think about this area with a lower bound, okay? What about that? the base is b minus a, and the height is m, so which means m times b minus a, okay? Do you agree with me, like this area is always less than this one because that is lower bound, okay? Does it make sense? Okay? Then what about with the upper bound? Upper bound is here, which is capital M. Then I'm talking about this area. Area of rectangle, base times height. And since it's upper bound for this function, this area is always bigger than this area under the curve, right? Always, okay? So like, this inequality is true for the upper bound and lower bound, okay? So look at that. That statement is over there, okay, in number 7, right? Again, if your function f has upper bound and lower bound, and the integral of your function will have upper bound and lower bound. That is the meaning of number 7 property, okay? So now let me give you a couple of more examples, okay?